student. Today we are going to discuss topic sequence and series from unit 3. So first of all we will start with the definition of sequence. What is a sequence? It is just a simple if a function is defined from set of natural number to real numbers, that particular function will be known as a sequence. So a function from n means set of natural number to set of real number is called a real sequence. If f n tends to r, then f of n is denoted by term an. The sequence can be written as a1, which means first term, a2 second term, up to so on an nth term. We denote the terms of a sequence by a1, a2, an. A sequence is an arrangement of numbers in definite order according to some rule. Then we have finite sequence. Based upon the number of terms in a given sequence, we can define any sequence as a finite sequence or a infinite sequence. So a sequence containing finite number of terms is called a finite sequence. For example, here you can see we have 9 terms. So this is a finite sequence because the number of terms are fixed up to 9. There are not terms more than that. But in case the sequence have infinite terms, the last term is not conformed for that kind of sequence is called as an infinite sequence. So further we have a limit of sequence, just like the definition of limit that we have done in our earlier classes. We can define the limit of a sequence whenever there is a very small difference between un and l, which is less than epsilon. Whenever n tends to infinite, that means n is greater than a number m, then this l is known as limit of a sequence. You can read here, let un be a given sequence if for given epsilon greater than 0 there exists some positive integer m such that for each n is greater than m. That means n is a bigger number which approaches to infinite. Difference between un and l is less than epsilon. Then un is called a convergent sequence and l is called the limit of a sequence. It is denoted by simply this function, that limit n tends to infinity of un is equals to l. After this we have few types of sequence. Convergent sequence. Simple, if any sequence has a finite limit and unique limit, then we can say that that particular sequence is a convergent sequence. That means all of the numbers of sequence should converge to one single point. Then divergent sequence, if there is not any if there doesn't exist any finite limit or there is no finite number to which the sequence contains, then this is known as a divergent sequence. Furthermore, we have oscillatory sequence. So sometimes we have a special kind of sequence in which there is not single limit. Limit could be 2. For example, if we have a function f of n is equals to minus 1 raised to power n. See, if n is even, that minus 1 raised to power n will become 1. And if n is odd, minus 1 raised to power n will become minus 1. So depending upon 1 and minus 1, this sequence could have 2 limits. Such kind of sequences are known as oscillatory sequence, that it oscillates between 2 points, 1 and minus 1. Then we have a bounded sequence. So whenever any sequence is bounded by a number, a sequence un is called a bounded sequence. If all of the terms of any sequence are less than a finite number, it could be m, right? Such kind of sequence could be known as bounded. Bounded means it is confined to a number. It could not extend more than that. Now if we have a sequence which is bounded as well as monotonic, that is known as a convergent sequence. For monotonic we will proceed our next definitions. Now here increasing sequence. Increasing means whenever we have such kind of sequence that previous term is lesser than the next term. Preceding terms will be always lesser than the next term. Such kind of sequences are known as increasing sequence. Here an is a given sequence. So if an plus 1 is greater than an, that means if a5 is greater than a4, a6 is greater than a5 and a7 is greater than a6, for each n greater than equal to m, then the sequence is called an increasing sequence. Further, decreasing, same process will follow. If the next term is lesser than the previous term, then it will be known as a decreasing sequence. So an is a given sequence. If an plus 1 is less than equals to an for each n greater than equal to m, where n and m belongs to m, then an is called a decreasing sequence. Then we have monotonic sequence, a sequence which is either keep on going on increasing or going on decreasing. That kind of sequence will be known as a monotonic sequence. Then we have geometric progression. In our 11th standard, we have already done this geometric progression. Whenever there is a common ratio between two consecutive terms, that kind of sequence could be known as a geometric progression. So, a sequence is said to be a geometric progression if the ratio of any term of its preceding term is same throughout. For example, you can say we have two terms. We will take ratio of second term with respect to first term and third term with respect to second term. So ratio should be equal in the terms. That kind of series or sequence could be known as a geometric progression. In other words, a sequence a1, a2, an is called geometric progression if each term is non-zero and ak plus 1 upon ak is constant. Further, we have done that this is a general form that an is equals to a into r raised to power n minus 1. And this formula you have already done in your previous classes, that sum of those n terms is equals to a into 1 minus r raised to power n upon 1 minus r if r is lesser than 1, and this will change if r is greater than 1. So this is that you have already studied in your previous class, that geometric progressions. So this is a sum of sequence, right? This is different. Now let us solve this example. Test the convergence of this sequence. Here, first of all, we have to consider let un is equals to 2n square plus n upon n square plus 1. This is your given sequence. Now we have to check that if the limit exists, then the limit is finite, then this will be convergent. If limit doesn't exist to a finite number, this is not convergent. So let us check, let us take limit. Now you can see n square is common in numerator and denominator. So take n square common out from numerator as well as denominator. N square will get cancelled with n square. In numerator we have 2 plus 1 upon n. Denominator we have 1 plus 1 upon n square. And then after cancellation of n square with n square, we have this term. After put limit n tends to infinity. So 1 upon infinite will become 0 and 1 upon infinite square will again become 0. 2 upon 1 is 2, which is a finite number. Now you can see, since the limit of this is a finite number, using this definition, limit is a finite number, hence the given sequence will converge to number 2 because the limit is 2. Next we have a ratio test. As the name pronounces, in this test we used to take ratio of any two particular terms and we will find out the limit. If limit n tends to infinite, u of n plus 1 upon un is equals to n, that limit exists, then this converges if this L is lesser than 1 and it diverges if this is greater than 1. But if this is equals to 1, then this test fails. Test the convergence of this sequence n factorial upon n raised to power n. Now here we have un is equals to n factorial upon n raised to power n. So this is nth term, we have to find n plus 1th term. Replace n by n plus 1. N is equals to n plus 1 factorial. So this n will become n plus 1, this will become n plus 1. Now let us take the ratio of this term with respect to this term. So limit n tends to infinite will be this. Now open this n plus 1 factorial, it will become n plus 1 into n factorial. And this term n plus 1, you can also open this power, which will become n plus 1 into n plus 1 factorial. Furthermore, you may divide this n raised to power n with this, it will become n upon n 1 plus 1 upon n factorial. N plus 1 factorial and n plus 1 cancel, n factorial will get cancelled with n factorial. So you have only 1 upon 1 plus 1 n raised to power n. Now you can put here limit n tends to infinity, 1 upon infinite will become here 0, which is exponential e. So 1 upon epsilon, as we know, e is greater than 1. So any number 1 is divided by a number which is greater than 1 will be definitely less than 1. Hence by ratio test, this sequence is convergent. Now we have text the convergence of a in this sequence. Let now nth term we have to evaluate here. How we will evaluate? Just subtract, this is an, take an plus 1, subtract an plus 1 from an, you will get that this is equals to 1 upon an plus 1. Now this is a definitely the next term is greater than the previous term, so this term is an increasing sequence. Now if an monotonic increasing sequence, that will be definitely a